sharing their experience from tech leaders to tech leaders. This is CTO Talks.
Hello and welcome. This is Marcin Brunowski, and I have pleasure to host today Erik Åsberg from eSmart Systems. Hello, Erik.
Hello, Marcin. Thank you so much for having me on your podcast.
Nice to have you here. Many thanks for accepting the invitation and coming over all the way from Norway here. So, Erik, could you give a bit of introduction about yourself, your background, as well as eSmart Systems?
Of course I can. So my name is Erik Åsberg. I'm the CTO of eSmart Systems. My background is from computer science. Been developing software for the energy industry more or less my entire professional career. So that's more than 25 years, doing everything from power exchanges to trading and risk management, CRM systems, and then we started eSmart in 2013. I started there as head of development and then became CTO after a few years. I also hold a role as a Microsoft regional director, which is sort of an ambassador and advisor for Microsoft. And I also I mentor startups for 6am and for Microsoft for Startups. So I find it super interesting also. Really glad to do that on the side. eSmart Systems is a software development company from eSmart, and we're a product company. So we develop our product, Grid Vision. The purpose of the product is to inspect infrastructure, power lines, and substations. And we use AI to do that. So basically computer vision to do that. We are a global company. We are based in Norway, but we actually have 19 different nationalities in 9 different countries. Our customers are mainly in Europe and North America, but we have customers on all continents. That was short about eSmart and myself.
Okay, so if you're saying that you use AI, it's not that, given the hype nowadays, there's a lot of startups that runs on GPT. Mm-hmm. So I assume it's some proprietary AI models.
Yeah, it is. So nowadays, all companies are AI companies. If you go to a startup event, everyone is an AI company. We started in 2013, been an AI company since then. Mm-hmm. We develop our own AI. Of course, based on known frameworks and open source frameworks, but still it's our own models that we develop because it's a very, very specialized task, what we do, to detect defects from images. Mm-hmm. So we develop our own AI and we're not someone who just consumes AI, we actually develop AI.
Okay, and actually that's going to be our topic for today. So I think it's quite interesting. Many companies, I believe, are considering now leveraging AI in some way. I assume that most of them think about low-hanging fruits, like using something that's available on the market. But eventually they may reach a point where they realize they need to create their own models, right? So I think that we could talk about what it really takes to build, or maybe not a startup, but build a competency within the company that's capable of running and building on machine learning models. And just before we get into that, so what kind of machine learning models you use? Do you do computer vision or?
Yes, so computer vision is the main thing that we do. We, of course, like all companies also are working with LLMs and those parts, but sort of the core of what we do is computer vision.
Okay, so could you reveal how is your engineering team built, and how it's structured, and what are the roles and responsibilities?
Yeah, and that's interesting because previously, we were organized in 3 different teams. Let's call it teams, where we had one AI team, we had one software development team, and we had one product team. What we've done the last year is merge those 3. And for us, that has been sort of a revelation almost. It's been a fantastic journey to see how we've speeded up everything when we've merged those together. And especially merging our data scientists with our software developers, that has been really, really fruitful for us. and I have some theories on why.
Okay.
But
but what was the motivation? So you must have had some motivation behind this
the
decision.
motivation was to get everyone more aligned, more product focused, more everyone to understand sort of why we're doing this, and have the same conceptions and same alignment on everything, so that we don't have sort of three silos. Even though it's under the same room and we're not that huge company, but sort of, you know how it is when you have three different teams that they get their own sort of thinking around how this should work. So we really needed to break that down, make sure that we run in the same direction. We ran in the same direction, but there were sort of small nuances of differences, and we needed to make sure that everyone was super aligned. So that was the motivation.
Probably towards the same business goal, not their like.
No, exactly, and that's part of the challenge, right? When you run sort of separate teams, they care about their own performance, but they might lose sight of the overall goal that we want to achieve, because everyone is closest to themselves, right? So you really care about your own performance, and the teams really cared about their own performance, and believe me, they are super good, all three of them. Now we've merged them to get everyone much more aligned.
So what roles do you have now? So, you know, if you're doing like a web application, it's quite clear you've got front end, back end, or full stack devs, QAs, product owners. But what roles you have in this kind of cross-functional team? Yeah. So
if we talk about the people that work now with our AI, we have. Of course, the data scientists. We have a data engineer. We also have annotators, both in-house and people or services that we buy. But we also now have software engineers who work closely with everything, the framework around the AI that we do. So that's maybe the biggest change, that we actually have software engineers that work closely with the data engineers. Because previously, our data engineers and data scientists, they had to do quite a lot of software development, actually, to build the frameworks around the AI that we do. But that is not their speciality, and that was part of the challenge. So when we merged this, we saw that, the software parts that are needed to support the AI, that is better developed by actual software engineers. And it was very obvious to us after a while that, we're making things much quicker on that side. We're moving much faster, and we're doing a better job, basically, because we can have specialists in software development doing the software development to support the AI. Not only sort of the software to do the product development, but to do the deep support that also the AI needs.
Okay, so it's also a better use of the competencies, right?
It is, but for us, it was a step change, really. So that was a huge learning for us, that having actual software developers work super close with the data scientist and develop all the frameworks that are needed to actually run a production-like setup for AI. That's different, and you need actually that competence and that knowledge. And you initially spoke about sort of how to scale, and we're going to talk more about that. And this is super important, I think, in how to scale AI. You really need that professionality, that skill set, really, really tightly combined.
All right. So before we dive deep into that, how about product ownership and within the team? Do you have a dedicated product owner, or is it like someone from the board? Because that's very common in the in startups.
No, we have a product. We have a head of product, a French lady, very, very good. But under her, we also have 2 product managers. Also extremely, I cannot say sort of I'm so proud of my team, so I have to give them a lot of credit. But we have
ask them to watch it.
Of course. But yes, we have a product organization. So under head of product, we have product managers, but also our UX designers, and we also have a functional architect. So that's how we organize sort of on the product side of things. Yes, and they own sort of everything on how to move forward, what functionality we should develop next.
Okay. So maybe for companies and people who haven't been doing this so far, could you describe a difference between a data scientist and data engineer? Because
yeah, and that I'm sure that differs also from company to company.
Probably.
Yeah,
Yes.
but I can talk to how it works at eSmart. So at eSmart, a data scientist typically work with the AI model as such, while the data engineer is supporting us creating the data sets that is needed to actually develop the AI. Because, of course, as all AI, the data is what you have that you need to develop our AI. And we have massive amounts of data in terms of images on our side.
Could you give a ballpark number?
There are hundreds of millions of images. Tenths of terabytes of images. Yeah. Of course, that is our gold, really. Our images is our gold. So it's super important for us to manage that in the best possible way to make sure that we get the most out of our data so that our AI is best possible. So the data engineer is supporting our data scientist to get those data sets as good as possible. So that's how we work. And we see that we are also moving more and more towards a data-centric AI, more than maybe a model focus that we were before. But we can talk more about that, I guess, because it's more also about the changes that we see in general in the AI space now.
If you could just continue, I mean, that's a very interesting topic.
So what we see, because since 2013, we've always developed our own models. But we see now there's foundation models that are coming out from Google, from Meta, from Microsoft. Free. Yeah, and they're open sourced. We're free to use them. Of course, there are certain limitations on some of them. But of course, you need to comply with those limitations within the license. But what we see is that some of those are really good, of course. And the question we're asking is, will we continue to develop our own AI? We know that the data that we have is our goal still. So for some of the models, we will definitely continue to develop ourselves. But we also now are looking much more into those models that are available. And we know that they are super good at separating cats and dogs.
Yes.
But they're not good at our very specialized vertical.
Niche applications, industrial applications.
Exactly. And I'm very sure that we are not the only one who have that sort of perception of these models. But we have so much data. So what I mean when I say data-centric AI is that let's look more at how we can manage our data, how we can get value from our data, and maybe then start using more and more the models that are out there. And instead of developing our own models, maybe we will more and more tune those models into our domain. So by tuning them, it still becomes our IP. So they're still ours because we take a general model, we tune it into our purpose, and it becomes our IP. But so that's what I mean by data-centric versus model-centric, where we traditionally are, where we developed all our models ourselves. So I think the future for us will be a combination, but we're moving more and more in a data-centric direction.
There is a question I ask myself, given the number of popping up startups based on OpenAI and ChatGPT. Don't you see, especially that it's the core of your business, yeah? So those models are the core of your business. Don't you see a risk in using licensed models that the license will change or the behavior will change of those?
There's always a risk, but I don't see it as a bigger risk with that than any other open source. They're open source licensed. We, of course, check what license they're under. I don't see it as a bigger risk using open sourced AI models than any other open source library. So I'm not too worried about that. It's more about we need to really utilize those models because we are the leader in our field when it comes to AI in use for these purposes. And we need to make sure that we are still in front of everyone else. And we know that we have an advantage with all the data that we have and all the knowledge that we have. So my thinking around this is, okay, there's a potential threat with the large models that are coming out, but we are ahead of the market. So if we are able to utilize that to turn that into an opportunity, and we're working really hard to do that, and I'm actually super confident that we are turning this into an opportunity, then we are still ahead. Because we are able to turn around and make this an opportunity.
Exactly. All right. So you mentioned about scaling AI. So I think that there's a lot of people doing proof of concepts. Basically, and there's, you know, if you look at LinkedIn, there's like a video after video of perfectly working AI, and it's all in very synthetic situation, right? But you do this for a living, so you need to run at a production scale. What would you like say about what are the key elements to run AI in production? Yeah, and what is the difference from like prototyping at home?
Yeah, and this is a very, very important question because we see from time to time, also among our customers, which are huge utilities, of course, they have data scientists, and they see that the problem we are solving by detecting defects in the power grid, they are thinking that, yeah, well, this is super easy. And actually, the first 5 models that you develop, they are easy. You have enough data. You take, of course, the most easy use cases that you have. And I would say that the first at least 3 models, anyone could probably do it. And it's easy with just running a proof of concept because you just do it in your own. You can do it on your own computer. You have everything you need right there, and then you can go to your boss and say, "Hey, look at this. It works," and it does. But the difference there is when to solve the problem that we're solving, you need like 50, 100, 150 models running in production. And you need that continuous improvement also of those models. So it's not only sort of, you define the problem, you gather the data, you build your data set, you do your training, you do your verification, then you set it in production, you deploy to production, but you're not done there. And that's the challenge, and that's the difference between running in production and running a POC. Because in a POC, you would be done by that. Then you have it in your production environment and you say, yeah, it's working. But when you are to maintain this over time, you need to still gather the feedback. You need to do monitoring of that model, make sure that it still performs, that it's not drifting. And then you need to gather that feedback. Then you need to redefine your data set, do the retraining, do the evaluation, do new deploy to production. And this is a circle that goes on forever. And you might do that for 3-4 models, it's easy to, but when you have 50, 100 models and you need to monitor those continuously and refine the data sets continuously, do continuous retraining, then it's a completely different setup. So
do you monitor precision of the models in production, like real time?
Yeah, we do, but we also, we get support from how we have designed the entire product, because our models work almost like copilots. So they advise the user on where to look in the images. Okay. And that feedback that the user give us then, because they say, yes, this is correct, yes, and they maybe say, no, this is not correct, from what the AI suggests. And that feedback is what we collect. And by using that, we can actually measure how our AI performs. And that is done throughout our entire user base across the entire world. So all our users are actually contributing to improving our AI.
It's like a CAPTCHA users on Google.
Yeah.
All right. And how about quality assurance? How is it different from like a regular software development, or is it anyhow different? How you make sure that you have no bugs in models, whatever that means?
No, it's a huge difference doing quality assurance on AI compared to ordinary software. So in ordinary software, of course, you have maybe your test cases that you run through, and you know that it's probably going to be used like this, so you're pretty sure that it works. in our world, of course, we define our data sets that needs to be balanced because we have global AI models that are used for all our customers across the world. And we, of course, have data sets that we use for verification. But that also is a limitation, right? Because some of the users will start using the models on something the model hasn't seen before. And it might be a different background, it might be a different structure that it hasn't seen before. So we always come into situations that are new to the model. And that's why we continuously need to monitor and perform. So that's why the QA is sort of, we can brag about, of course, our precision and recall in our testing and verification. But that's kind of wrong because the user will experience it differently. So we really don't like to talk about our precision and recall because we know it's super good.
Yeah.
That's not a problem. The problem is the expectation that it sets for the user, because we can say, it has a
perception.
Yeah, exactly. Because we set some expectations by revealing our numbers. For us internally, it's super important to have good numbers so that we can be confident about the model that we release. But it still sets some expectations that we are really, really careful about. And we learn this the hard way because really the numbers that we have is based on a very good verification data set. But that verification data set might not match what the user will put in. Exactly.
Especially if you expand it globally and you maybe start doing the same inspections in a different country. Like if you go to Middle East, you've got a lot of sand around, right? So.
Yeah, you don't know exactly. And it doesn't have to be that different either. But we cannot, so we always strive to build the best verification data set, of course. But it will always be small differences from the real world. So that's why we try to find different ways of measuring our AI than precision and recall. So what's the difference?
That's really interesting.
It is. And we worked so much with this because we see that how to set the right expectations for our AI. And for us, in our tool right now, it's more about, does the AI actually support you or is it noise? So is it if there's too many false positives, it's just noise for the user, telling the user to look here, no, it's not a defect, look here, no, it's not a defect. Then it becomes noise. So we are instead trying to count if the AI is actually supporting you in your job. And we do that by that feedback that I talked about, collecting that feedback, and we can measure how many times has the user accepted it and how many has the user declined it. Because then you get the actual efficiency gain that we get. So,
and this perception is more or less there, because if someone needs to correct the result every once in a while, then...
So back to your question, that was a long question, a long answer about QA. QA is very different, at least on how we use AI.
And do you have like a dedicated role in every team, or how who's responsible for that?
No, not for QA within AI. It's more the team as such, who we really actively use the metrics and share that amongst the team. So every role know what to do to improve the performance. We of course have QA engineers on our product side, but again, it doesn't make much sense sort of to have the QA engineer just verify that our validation data set performs. And we keep that in the AI team because it's a fully automated process. It's more about setting the right expectations in terms of QA for AI.
Okay, a common challenge, especially if you want to do this in production, is an access to data sets, right? To the right data. It's usually a case in the very beginning. I assume it's not an issue for you anymore.
Well, certain, because they're always... So now we're working with a Brazilian utility. They have different problems that we haven't seen before.
Okay.
So from time to time, new things come up. So
how do you make sure you have enough data to...
that's actually a commercial discussion, believe it or not. For us, it's important to get data, example data from our customers. And the customers, of course, they understand this. Everyone now know that data is a prerequisite for using AI in the best way. The challenge is often that people don't understand how much data that is needed to create good AI. That's the first challenge. The second one is, how do you manage that data? Who owns the data? How can you utilize that data? So we worked a lot on the commercial and legal side to make sure that we can build our data sets, basically, so that we can actually have data enough to solve many problems. And we did discuss a bit last night about how we're actually, when we do inspections and customers are doing inspections, the purpose of that inspection is for one thing. So the images are annotated for one purpose, but there might be other interesting things for other problems in that image. And that's why we've developed systems that really can crawl all our data to look for things that might not be annotated in that image, but still is there, so that we can increase the value of our data.
Okay, so basically, if the client doesn't have enough images for you to train the new model or updated model, then you look in your whole database for like similar images, something like this?
Yeah, so of course it's a challenge if the customer does not have enough images. But what we do, we utilize what we have from before, but we also work with synthetic data, and we augment images that we have, so we can twist and turn, change the background, make sure that, so we increase the training set based on data that we have. But we also work with synthetic data, building synthetic data sets from gaming engines. But what we've seen is that the quality is really not that good enough yet to completely trust only synthetic images. So we can augment a data set with synthetic images. That's sort of how we can still.
Have you tried some generative AI approaches?
Yes, of course. And we use Stable Diffusion for certain parts, but that is more to increase sort of the data set on existing images, so we can create things not fully synthetically, but we can alter existing images a bit. So that part works. Completely synthetic images, it also works to a certain extent. We can fill, but it's not possible to train on, or what we see in our experience is that the quality doesn't get good enough when we train it solely on synthetic images, so pure synthetic images.
Okay. And you mentioned about annotators. Yeah. So for anyone who doesn't know, if you're doing supervised learning, then you need to manually tag, annotate, or label. There are like various terms. Label the images. So basically, there needs to be a human being selecting certain objects on the screen, and saying what it is. So you cannot avoid this. Now, from my experience, is that the quality of annotation also matters. Very often it's like pixel precision things that can make a huge difference. And you mentioned that you have your own annotators as well as you use external services. So have you faced this problem or any other problem with good annotation quality?
Yes, we do that, and we also actually use the images that are annotated by our customers, our users. And yes, of course, the better the annotation, the higher the quality. So we have sort of internal guidelines on how to do annotations. There's new technology now that are supporting us, like segment anything model from Meta is one. So we're getting into automation there as well, but we still are dependent on annotations. So we've developed guidelines really to how to do it.
Anyone who supervises it, or
you can
just see it in the results?
We have internally one team member that actually is responsible for annotation, also for the annotated images that we get from external sources or external services. And I have to mention that external annotation services has sort of a shady rumor, because it costs very little, and you may wonder how can people live from this salary, and we wondered too. There's actually a startup in Norway called Naya, and they are turning ethical annotation into a business model, and it doesn't cost much more, but they have this ethical approach where they actually are
No children
providing
abuse.
totally transparency. They are providing education on the side as well. So they're actually, and these are people maybe living in slums in India, but they are helping these people by giving them a job, an annotation job, providing them with education. So it's a fantastic model.
It's really great.
Yeah, it is. So we just started working with them, and I'm super happy about that cooperation, because then we know at least this is done well, this is done real properly, and we're actually supporting someone as we do it.
And with the whole like ESG movement now, it's becoming more and more important and prevalent, right?
It is, absolutely.
Okay. So this person that's responsible for annotation in your team, is it like a part of the product team?
Yeah.
Okay.
It's part of the product team.
Okay.
Yeah, absolutely. So working closely with our data engineer, of course, to see, where are we low on annotations? How do we need to? So working closely with our data engineer.
Okay. Now, usually when the discussion about AI comes into place, there's a natural topic, infrastructure. So probably it's a common knowledge now that training and running machine learning models require quite a lot of computing power. Yeah. So how do you deal with that? Well, what kind of how do you run your infrastructure? Is it cloud-based, on-premise?
So it's a huge topic because it's a challenge, especially now when we're moving into those foundation models that we need to tune. So we have a combination of everything, basically. We have GPUs in-house. We are using several cloud providers and providers for different purposes. So we're using GCP, we're using Azure, and also other providers that provide us with H100s and those huge graphic cards that is needed. And especially now that we're tuning more and more foundation models, it's becoming a challenge for us. It's not impossible to get hold of them, not at all. It's the price that is the challenge, because we need to do this efficiently. So we're looking at several different options, and it's a continuous sort of quest for more computing power. We're doing fine on our sort of ordinary models, the ones that we develop ourselves. Those we have full control over. The challenge is more sort of on the tuning of the foundation, the large models. So we're looking at several alternatives and how to do this most efficient.
Now, I'm not sure if you can tell this, but out of your whole product budget, costs, all of the costs, how much of it goes for infrastructure?
So we have two sort of main cost centers in my department. It's people, of course. We have highly skilled people that are absolutely worth every penny that they get. And the other one is infrastructure.
It's more or less the same.
No, the people are actually more expensive than the infrastructure, but still, it's we use a lot of money on infrastructure. But then again, it's sort of, we are a global SaaS company. We provide our services. The product runs in Azure. We use GCP to build our AI, which we then move to Azure for inferencing and for running the product. It's important for us to work with those providers because it's also a scaling opportunity for us. So when we expand to new geographies, there's a data center there that can be utilized. So it's also sort of, you might say it's expensive, but also it's an opportunity for us to run this operation safely and securely globally and worldwide.
Okay, so maybe it's not obvious, but why is it important to have the data center closer to where you provide the services?
For us, it's two reasons. Of course, it's the performance. So the perceived performance of the user. If we are to travel that signal,
smaller latency, basically.
Yeah, exactly. That's one thing. But we're also working in a regulated business. So often, for instance, our EU clients, they do not permit us to move the data to the US or anywhere else outside the EU. Our US customers, they do not permit their data to go outside the US. So that's sort of the regulations that we need to comply with. And of course, then running on global hyperscalers like Microsoft and Google, that really supports us running our business.
Okay. One thing I wanted to ask about, also related to infrastructure. So, from our experience, we very often when trying to leverage, cloud GPUs, face the problem of lack of availability of GPUs at cloud. Yeah, and sometimes it can be an issue if you need to move fast. Basically, if you cannot wait for the GPUs to become available. Therefore, this is why we switched to our own GPUs. But is it still an issue because it's been like a few years ago? And
a few years ago it was definitely an issue.
Yes.
It's much better now. Much better. The challenge is more that the larger GPUs have a price that is difficult to defend. Really, it's so pricey that it's a challenge.
You could buy it on your own.
That would be cheaper, but then you lose sort of some of the other good things about it. So it's fully possible to get hold of now, much easier. The challenge is more the price. And of course, as a SaaS company, we talked about cloud spending. It's a huge cost for us, so we need to really have super control over our costs. So then it's sort of, can we do this? Can we do this training now? What are our options? Can we spend more time because we run it on less performant hardware? It will take longer. Is that okay? Sort of those questions and discussions are ongoing all the time.
Okay, maybe also coming back to annotation, called one thing. So usually to provide this annotation process, you need to have a tool that handles this, basically. And recently there's been a number of online tools also provided by Amazon Recognition, for instance, or the Snowflake recently bought Landing AI. Do you, for annotation purposes, do you use any tool available out of the box, or it's something do you build on your own?
No, we actually use, for annotation purposes, we use a tool out of the box, Encode. But it's on the back end, it's tightly coupled to our own data management system, which we have developed ourselves.
So just the front end, okay.
Yeah. So we use that front end, and then on the back end, we have our own system to manage our entire image. Let's call it a database, but storage or whatever we call it.
Okay.
And we've developed also methods to crawl our data automatically, so that we easily can find things that we're looking for in our monstrous-sized image database.
This crawling, is it some kind of a search? Are you able to
so we're actually using another foundation model. So we're utilizing something called Dino, also from Meta, that we have developed to crawl our own images to find similar things that we are looking for. And again, back to that challenge that the annotation of the images is done for one purpose, but now we want to use that image for another purpose, and it's not annotated. So we use this crawler that we developed to actually identify images that we didn't know we had, basically.
So if it's crawler, it's like goes through all the pictures when you So it's nothing like you have an index that you can search. Because I'm asking because a very common use case nowadays is having this kind of semantic search feature for images or text, and I haven't heard of like, you know, a solution that would be really working.
No, and of course it's also a challenge. We use a combination. So when we do annotations, we also tag the images. So it's a combination of semantic search and image search in image search. So we haven't. Yeah, that's also something we are continuously refining. But it's a combination actually of annotations and tags basically, and true image search.
Okay, so slowly wrapping up. If you were to advise someone who wants to build a AI-based startup, what would be like, you know, one or two things that you say are the crucially important to take into consideration?
Yeah, that's a very good question. So find someone who you need a combination of a really good software developer and a really good data scientist that knows sort of the AI technology. If you find that combination and you find them to work together good, then you're in a good position. Because they're very good data scientists and they're very good developers, but in our experience, having them working together very, very tightly, so that actually the software moves much more into, I wouldn't say the data science space, but the frameworks around it, then you're able to move much, much faster. So if you're thinking about moving into AI, everyone is thinking. If you're not into AI already, you are thinking about it, right? But do not sort of be satisfied with having only a superstar data scientist. You need also a superstar software developer, and those two in combination, in really, really tight combination. That I believe is what will give you gold.
And I think it's also important not only for startups, but I think that it's quite common for larger organizations to have a separate like data team, which historically have been data teams, which now deal with also machine learning models. And it's a different silo than regular software development team. So I think it's a good advice not only for smaller but also for bigger organizations, right?
No, I really, really believe so. And we're back to that point about doing POCs versus actually running things in production.
Exactly.
So that's the challenge.
All right. Many thanks for coming over, Erik. I think it was a very interesting episode. So if there is anyone who has any questions to Erik, feel free to leave a comment or reach out to find directly to Erik on LinkedIn. He replies. I can confirm. Thank you very much.
Thank you, Marcin. Thank you so much for having me.